And today I will be addressing hamamelatenin in combination with azithromycin as a possible growth inhibitor for common bacteria in surgical site infection. Surgical site infection is an infection that takes place usually within 1 and 30 days of post-operative patients. It is an infection that occurs when near the area of the opening site of the surgery or where the surgery was being taken place. There is an occurrence rate of 2 to 5% in post-operative patients that will develop surgical site infections. Depending on the anatomical location, the occurrence rate will either be higher or lower. Surgical site infections have been found to be produced by the formation of Staphylococcus aureus, Pseudomonas aeruginosa, and E. coli biofilms in the opening site of the surgery. To prevent this, doctors in the past have used antimicrobial-coated suture thread. However, the main suture thread that was used, which was a triclosan-coated VigroPlus brand surgical thread, has recently been banned because in this past September, triclosan was released as banned by the FDA. So since this happened, there has been a new need for an antibiotic coating to replace it. A large problem with doctors today in the treatment and prevention of infection is antibiotic resistance. 2 million people become infected with bacteria that is already resistant to antibiotics annually in the United States. And it has been found that 23,000 of these people die each year as a direct result of these infections. Antibiotic resistance basically happens because of natural selection, as if you have a large population of bacteria and there's bacteria that is resistant to antibiotics and bacteria that isn't, the bacteria that are resistant have a higher chance of surviving when the antibiotics are treated for the infection. And it also can happen with bacterial communication with resistance. This communication is called quorum sensing. Quorum sensing is basic bacterial cell-to-cell communication in which signaling molecules that are specifically made are used to coordinate gene expression among local populations of bacteria, and this is used to create the colonies of bacteria as well as help in creating antibiotic resistance. And because of this, the medical industry has recently been focusing on finding and labeling compounds that could be labeled as quorum sensing inhibitors to address these issues. In this study, I will be using 2 antibiotics. The first one being azithromycin. Azithromycin is a general antibiotic that inhibits the growth of bacteria by attacking the cell membrane. But more specifically, it has been found recently to be a quorum sensing inhibitor for Pseudomonas bacteria. Azithromycin is not related to penicillin antibiotics, therefore they have a wider range of treatment availability, seeing as up to 10% of the people in the United States have been reported being allergic to penicillin-related antibiotics. Hamamelatenin is the second antibiotic that is used, and it is a major active component in the bark of the witch hazel plant. And it has been labeled as a quorum sensing inhibitor for Staphylococcus bacteria, seeing as it inhibits the expression of RNA3 and Staphylococcus quorum sensing processes. It is not expected to inhibit the growth on its own when I am using my Kirby-Bauer diffusion assay, but it is expected to increase the antibiotic susceptibility of the bacteria when treated with azithromycin. Staphylococcus epidermidis was used because of safety issues with Staphylococcus aureus in our lab. The Thousand Oaks High School lab is a biosafety level 1 lab, therefore Staphylococcus aureus and other bacteria cannot be used. However, it has been used as a model organism for it in other studies that I have read, as well as being similar in being gram-positive and being a facultative anaerobe. Other materials used include an incubator for overnight bacterial incubation, an autoclave to ensure sterility of individual products, blank susceptibility discs were used to impregnate the azithromycin and hamamelatenin, and Staphylococcus epidermidis was the organism that was being tested against. Tryptic soy broth was used as a rehydration medium for the lyophilized Staphylococcus epidermidis powder that I received from ATCC, and for the diffusion test, I used mannitol salt agar for the Petri dishes because of its nutritional values for the specific My hypothesis for this experiment was that adding hemamyelinatin to azithromycin will increase the antibiotic susceptibility of Staphylococcus epidermidis due to its ability to inhibit the quorum sensing aspects of it. And to test this hypothesis, my methods basically contain 3 major steps. The first one being disc impregnation, the second one being individual dose response, and the third one being the combined dose response. For disc impregnation, the discs were found to be able to absorb 30 microliters of solution, and basically 30 microliters of each antibiotic solution was added to each blank antibiotic susceptibility disc and allowed 30 minutes to fully absorb and dry, and then they were transferred into separate Eppendorf tubes containing only discs of the same antibiotic solution in order to continue consistency throughout the project. And steps to prevent contamination during this stage in the project was that this phase was completed in a laminar flow hood, and that was so that the antibiotics would not be contaminated by airflow in possible lab settings. The solutions and the pipette tips and the discs were all autoclaved before experimentation began to make sure that nothing would be already existent within the individual materials, and gloves were worn in order to prevent possible contamination from outside sources. The concentrations of each antibiotic consisted of their own concentration gradients. Azithromycin ranged from 0.05 micrograms per milliliter of DiH2O down to 1.5 micrograms per milliliter of DiH2O. And hemamyelinatin was a gradient between 1 microgram of hemamyelinatin per mil DiH2O to 30 micrograms of hemamyelinatin per mil H2O. And then with the combined stage of the experiment, what I did was, after the individual dose response, I found the best concentration with the most effective antibiotic capabilities between the azithromycin, and then I added it individually with each concentration of hemamyelinatin to see how the different concentrations would adjust the effectiveness of azithromycin. I used the Kirby-Bauer diffusion assay to see the antibiotic abilities of azithromycin and hemamyelinatin. From this figure, you can see how the plates were organized. What I basically did was I had 11 discs total for the initial project, the first 5 being for just the azithromycin dose response, the second 5 being used for the hemamyelinatin dose response, and the last one being used as a control. Now, the control disc had blank antibiotic susceptibility discs that had nothing in them already to make sure that the discs themselves did not tamper with the results. This process was completed in the fume hood, and after there was 100 microliters of bacteria spreaded on these plates, and then that was allowed 2 to 3 minutes to dry before adding the antibiotic susceptibility disc at an equidistant location from the middle for each one. And this was completed in triplicate, and after 24 hours of incubation at 37 degrees Celsius, the zone's diameters were measured with a ruler in millimeters. From this test, I found that at 1 microgram of azithromycin per milliliter of DiH2O, the average peaked, and that this was the one that I should use for the synergistic dose effect, which is the next part of the presentation. So after finding that in the individual dose response, I carried that information with me when I completed the combined dose response. I used the 1 microgram of azithromycin per mil DiH2O since it provided the largest zones of inhibition among the 5 concentrations of azithromycin provided. And I combined them with each 5 of the hemamyelinatin concentrations as seen. From this, I found that at 10 micrograms of hemamyelinatin added to the initial 1 microgram of azithromycin, that the zones were increased substantially when compared to the azithromycin by itself. Here is an image of a sample of the zones. As you can see, the discs were placed equidistant with the lawns, and the clear zones around the discs were the zones of inhibition. Here you can see a graph that explains how the difference between the control at 0 micrograms of hemamyelitanin added to the azithromycin compares to the 10 micrograms of hemamyelitanin added to the initial 1 microgram of azithromycin. And it was found that at this concentration combination that the results peaked. And from this, I found that the addition of hemamyelitanin to azithromycin improved azithromycin's initial antibiotic effectiveness by 25%. And through statistical analysis, I found that from a t-test that my null hypothesis could be rejected due to the measurements all being statistically different enough to be significant. Although there are existing limitations to the Kirby-Bauer diffusion assay, such as the viscosity of the culture medium and the rate of diffusion of the antibiotics, as well as the consistency of concentrations of the antibiotic on the filter disc, and the possible toxicity problems within the two different antibiotics contradicting each other. I just used it to provide a basis for defining this. This is not the last step in this project. This project is something that could apply to the human body, therefore it requires many more further work studies. And to address these, for the viscosity of the culture medium, I took the optimal densities of each of my cultures before use, and I only used the cultures that had similar readings from the optimal density readings. The rate of diffusion could be addressed by me using the same brand for all of my studies of the blank antibiotic susceptibility discs, and the concentrations were all organized as you saw below. And I knew that the discs all fully absorbed the same amount because before I started my experimentation, I tested to see at what volume added to the discs would completely absorb it and which would pool over. And I found that at 30 microliters, it absorbed it completely without pooling over. In conclusion, the results from this show that the addition of the synergistic effect of azithromycin and hemamyelitanin together are far greater than the antimicrobial effect of either agents individually. So with the application of this agent in the medical field, the rate of surgical site infections could possibly decrease if coated on surgical suture threads. Also, if a chromosensitive inhibitor is designed for the most threatening of bacteria, doctors can lower their patient's likelihood of infection substantially before they get it. And further works for this study is I would like to test azithromycin against the 3 main bacteria that I addressed in the beginning that are the main culprits of surgical site infection, including Pseudomonas aeruginosa, Staphylococcus aureus, and E. coli. I would also like to thank Dr. Nikki Malhotra, Mr. Jeff Lewis, and Dr. Charles Henley for their support, advice, and guidance throughout my project. And there's some